Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And I want us to introduce ourselves to topic number 8. This is chapter 8 of Pure Mathematics 3, and we're going direct to page 159 to discuss something to do with numerical methods, and the subtopic is locating roots. And as such, I want us we read together this statement, which is saying a root of a function is a value of x for which fx is equals to 0. That we know. And the graph of y is equal to fx will cross the x-axis at points corresponding to the roots of the functions. You can sometimes show that a root exists within a given interval by showing that the function changes signs from positive to negative or from negative to positive within the interval. What we are saying is this: if you happen to have a general function like this, and that function could be a quadratic, y is equals to fx, and then we have it crosses the x-axis at x1, it also crosses the x-axis at x2. Of course, we know the x-axis, its mathematical name is y is equals to 0. And when this function is 0, then we have this as roots. We call these roots. Some books, we call them solutions. Solutions of functions is when the graph cuts the x-axis or the line y is equals to 0. And anytime you substitute these roots in the function, you will find your answer is 0. And especially if you're talking about quadratic functions, you only solve them when they are equals to 0. And therefore, you can talk of a quadratic function of any nature, but these are the roots. Now, we are being told that it happens that when you have a graph, probably I will talk about A and B. And I want to explain what is in bold here. We are told that if the function fx is continuous on the interval a and b, then fa and fb have opposite, and fb have opposite signs, then fx has at least one root, x, which satisfies this particular statement. And I'm going to explain. When you have a function of this nature, and at this particular point, this is y is equals to 0, or the x-axis, this could be y, and this is y is equals to 0, or rather x-axis, and we have the value of x being a, then we may have y, which is fa here. It could be positive, it's on the positive side, and we may have y is equals to fb, which is on the negative side. Please note, anything above the x-axis, y is positive, and this is positive, and this is negative values of y. So it happens that when we have the function of a being positive, and probably the function of being negative, and the function is continuous, it could be that regardless the shape, it could even have some shape that looks like this. It could even have some shape like this, that is fb, and this is fa. You realize that there is a certain x there where the graph cuts the x-axis, and this happens to be the root of that function. The major thing is that there is when the value of y was positive, and there is when the value of y was negative. The fact that it has changed sign from positive to negative, it means it must have crossed the x-axis. In other words, at this particular point, fx was equals to 0. What I'm trying to say in all these words is that 0 is between negatives and positives. That's what I'm trying to say. If you want to walk away from 0, if you go up, you will go to the positive. If you go up, you will go to the positive. If you go down, you will go to the negatives. That is simply what we are saying. If you go up, if you go down, you will go to the negatives. We are simply saying that 0 is between positive and negative numbers. Therefore, in the bold, when we have FA and FB, they are in opposite sides. Then fx has at least one root x, which satisfies that x is greater than a and less than b. You can already see if x happens to be here, then it is to the right of a, then x is greater than a. And then x, if this is the root, it is to the left of b, then it is less than b. And that is just like that. And with that, I want us to use the next video to explain example 1, example 2, and example 3 moving forward. So that is just like it, introduction, and we have seen it, introduction of numerical methods. Let's leave it at that. In the next video, I'm going to explain example 1. Okay.